These are notes from Elham's Math 60 for Wednesday, April the 29th. We're up to section 9.6, page 824. Today we're doing properties of logs. There are three big ones, the properties of logs. The log base b of x times y is the log base b of x plus the log base b of y. Please notice that you're multiplying here, but you're adding here. The language you might hear is the log of a product is the sum of the logs. There's a product here and a sum here. Next one is log base b of x over y is equal to log base b of x minus the log base b of y. Sometimes you hear the language, the log of a quotient is equal to the difference of the logs. Quotient here, you're dividing, difference over here. And the third property of logs, log base b of x to the nth power, that n can come down in front, as you can see here, n log base b of x. And all three of these are reversible. In other words, it doesn't have to be going from left to right. It could be going from right to left, and some of the homework problems show that. Okay, in problem 19, it says the log base 6 of 1. Okay, in red here, I went ahead and put equals x so that we can unscramble it. 6 raised to the x power is equal to 1. And you might recall if you raise anything to the 0 power, it's equal to 1, so x is equal to 0. Both 23 and 27 use the fact that the exponential function and the logarithm function are inverse functions of each other. So in other words, 5 to the x and log base 5 of x are inverse functions of each other, just like ln of x and e to the x are inverse functions of each other. So if you ever do one immediately followed by the other, they cancel each other out. So 5 raised to the log base 5 of 10, all of this cancels out and you just have 10. 27 likewise, ln and e cancel out, but you might say if I cancel this out, there's nothing left. The trick is to pretend that there's a 1 here, because e is the same as e to the first power, so ln e to the 1. Then ln and e cancel out, so your answer is just 1. Then 31 here, log base 2 of 4 times 5, so that kind of looks like that one. It's a log of a product. Right, so I'm using this side now, log base 2 of 4 plus log base 2 of 5. Now log base 2 of 5 isn't a nice number, but you can figure out log base 2 of 4 if I temporarily call that x. In other words, log base 2 of 4 is x. Unscramble it. 2 to the x equals 4. So you're saying 2 raised to what power is 4? Well, that of course is 2. So now I can rewrite this answer as 2 plus log base 2 of 5. So the final answer is 2 plus log base 2 of 5. 37, you have the log of 5xyz. When I write 5xyz, we know it's all multiplication, so I'm just using this property many times. It's the log of 5 plus the log of x plus the log of y plus the log of z. And you don't really need it for this problem, but a little reminder, if you don't see a base here, you pretend that it's base 10. It's understood to be base 10 unless we say otherwise. And of course, on your calculator, when you see the button log, L-O-G, that means base 10. Here for 41. Log base 6 of x over 36. So this looks like this one, the log of a quotient, something divided by something. It's the log of the top minus the log of the bottom. So log base 6 of x minus the log base 6 of 36. Can't do anything with this, but we can work out a little bit more on this one. If I call this thing y, in other words, log base 6 of 36, call it equal to y. Unscramble it. 6 raised to the y is equal to 36. So what exponent do I need up there? Well, that would be 2. So my final answer, I just replace this with 2. So the best final answer for the original is log base 6 of x minus 2. Here's 45. Log of 10x over y. Notice there is no base here, so we understand that it's 10. So I snuck in a 10 here, and I sneak in a 1 here for emphasis later. So it's a log of 10. This is a multiplication, so it's times here. So you add here log of 10 plus the log of x. And since this is division, then it's minus the log of y. Can't do anything here, can't do anything here, but the log of 10 is just 1. You understand that the base is 10, and I sneak in a 1 here. So that's kind of like the problem that we had with ln of e. These just cancel out, and so we just leave it with a 1. So final answer is 1 plus log x minus log y. 51 says ln of y to the 7th. All you do is simply move the 7 out in front, so I'm using this property here. Exponent just comes in front, so 7 natural log of y. Again, ln stands for natural log or log natural. The base is e in that particular case. 57, log base 7 of 5th root of 100 cubed. what you want to do here is first rewrite this as a fractional exponent. The fractional exponent, the top is the power, the bottom is the root. Root of 5, power of 3. And now I'll again use that property there that that exponent can just sneak in front. So 3/5 log base 7 of 100. Okay, then for 61, log base 2 of 2 cube root of x divided by y. First I'll rewrite this as x to the 1/3 power. That's what cube root means. So it's a log base 2 of 2. Since this is multiplication, I add log base 2 of x to the 1/3. And since this is a division, it's minus log base 2 of y. And once again here, log base 2 of 2, I'll sneak in a 1 here. These will cancel out. Remember the exponential function, 2 to the x, and log base 2 of x, they're inverse functions of each other, so I just make that 1. And I sneak the 1/3 in front, so 1 plus 1/3 log base 2 of x minus log base 2 of y. Okay, here's 67. Log base a of cube root of x divided by 4th root of yz. First I rewrite this as fractional exponents. Cube root means raising something to the 1/3. 4th root means raised to the 1/4, and I distribute it so each of these are to the 1/4 power. Okay, so we have log base a of x to the 1/3. This is in the denominator, so it's minus log base a of y to the 1/4. And this is also in the denominator, so it's also minus log base a of z to the 1/4. And then using this property over here, the 1/3, 1/4, and 1/4 all come down in front. So notice 1/3 comes out in front, 1/4 comes in front, 1/4 comes in front. So the final answer is 1/3 log base a of x minus 1/4 log base a of y minus 1/4 log base a of z. 73, ln of square root of ex. Well, this means raised to the 1/2 power, so ln of ex to the half. And then I'm using this property right here again. The 1/2 gets to sneak down in front. 1/2 ln of ex. And now here we have a product. So that looks like the first one, ln of ex is ln of e plus ln of x. Sneak in a 1 here, and ln and e will cancel out. The natural log function and the exponential function are inverse functions of each other. So they cancel out, leaving me with just a 1. So the final answer is 1/2 times 1 plus ln of x. Then we have some problems where we're going the other direction. They write it like this, expanded form, and they tell you to write it as a single log. So log base 3 of x plus log base 3 of x plus 2 minus log base 3 of 8. Write it as a single log. This is an addition, so I write it as a multiplication. This is a subtraction, so that's going to be a division. So log base 3 of x times x plus 2 divided by 8. You can leave it like that. No need to multiply out the x times x plus 2 if you don't want to. But if you want to, that's also okay. And 87, 1/3 log base b of m squared minus 9 minus log base b of m plus 3. So since there's a minus sign here, I will divide the individual logs. So 1/3 log base b of m squared minus 9 over m plus 3. Continuing up here, notice that m squared minus 9 factors into m plus 3, m minus 3. And very conveniently, the m plus 3's cancel out. Okay, so I have log base b of now m minus 3, but I can take that 1/3 and sneak it back up. So I'm using this property in reverse. Right, so we're going from right to left, as it were. The coefficient can sneak up there as an exponent. So now I have log base b of m minus 3 to the 1/3 power. And we know if we raise something to the 1/3 power, it means cube root. So log base b of cube root of m minus 3. And finally 83, they give it to me as ln x over z plus x minus ln of y over z plus y. There's a minus here, so this is the right-hand side of this, so I'm going from right to left. I write it as a division. So it's ln of x over z plus x over y over z plus y. We can simplify that. We don't like the way it looks. So the common denominator here would be z, so I multiply the top and the bottom by z. So I now have ln of z's cancel at x plus xz, and on the bottom, again, z cancels out y plus yz. And then I can factor an x out of the top, and I can factor a y out of the bottom. So it's ln x times 1 plus z over y plus 1 plus z. Very conveniently, the 1 plus z's cancel out, so my final answer is ln x over y. Alright, so these are notes for Melham's Math 60 for Wednesday, April 29th, 9.6. So tomorrow is 9.7, Thursday, and that'll be the last section for Chapter 9 before we have the Chapter 9 exam.